Okay, welcome back. Now we're going to continue on from where we left off on slide 28. So we were going to talk about how we progressively become stronger in format and less vulnerable to update anomalies. So if we want to look at it graphically, the way we might look at the process of normalization is we are constricting we're tightening our graph on what we can do with our database table. And now out here in this external region, we would call this the unnormalized form. It's just data in bulk. It's data just thrown together. Then we'll talk about today, before the end of this lecture, we'll talk about what the first, second, and third normal form is. The next set of lectures will discuss the Boyce-Codd normal form, the fourth, the fifth, and some higher normal forms. I can tell you from experience, as far as this course is concerned, the third normal form is going to be the highest normal form that you probably deal with. Those higher normal forms, Boyce-Codd, fourth and fifth, they may come into play with enterprise systems, large database systems, your Amazons, Googles, Netflix, shopping websites, stuff like that. But as far as your group project, the third normal form is plenty sufficient for what you're probably dealing with. Okay. Okay. So we're going to go through a process of taking an unnormalized form of a database. We're going to bring it into the first normal form, right? Then we're going to bring it into the second, and then finally the third. Okay. What you can see, what we're going to talk about is how removing repeating groups. What does that mean? Right? Removing partial dependencies and removing transitive dependencies. Okay. So an unnormalized database, a table that contains one or more repeating groups. So we just take a set of data and bring it into a table format with columns and rows. That table format doesn't have to be a database. It doesn't have to be a MySQL database table. It could be an Excel spreadsheet. It could be a comma-separated text file. There's all types of possibilities. Okay. But it could have repeating groups. So it's probably how you would probably see a lot of data that you just kind of throw together just for tracking, just for keeping up with. Okay. So we're going to take that unnormalized form and we are going to create what we will call a first normal form relation. Okay. Now the first normal form simply means that every cell has one and only one value. Now, when I say value, I don't mean one character of a string. A string value, a name, an address, those can be one value. It just means that for every intersection, every cell, there is a value there. There's not multiple values that can be contained in that cell. Okay. So, for example, if maybe we had one column that was maybe a customer, right? A customer name, right? And then the next column might be their payment type, like how can they pay, and then another column might be their address. So this might be like Pt2, for example, might be an example, something where this might happen. Okay, so your customer name, right? My name. Okay, payment types. Well, sometimes I use credit card. That's really nice, especially these days, right? We use credit card a lot. Where they don't want to have a lot of people touching other things. Okay, and maybe you might have an address. You might have a home address. Okay, but then you might, for the same customer, have another payment type they can use, and you might have another address they can use, right? And so the way this would look in a unnormalized form would say this customer can have multiple payment types and multiple addresses. Okay. Now the first normal form will not allow this. Will not allow multiple things here. So what we'll have to do is, we'll have to, instead of having this, now we need every cell. So we'll just duplicate it out. So every cell that used to have multiple values now is going to have one and only one value. Okay. Okay. So this will be how we would branch that out. Okay. All right. So moving on. So the first normal form would look something like this. Now, one of the things that we're also going to create in this first normal form will be that because every row will have cells that contain only one value, it means we can define a primary key. So what we're going to do is we're going to define a primary key for this table. I'll show you how to do that with an example in the next video. Now we'll move on. Okay. So how to bring our data from unnormalized to first normal form? We take an attribute or group of attributes to act as the key, the primary key for the unnormalized table. We identify any repeating groups, right? And we remove those repeating groups by entering appropriate data into the empty columns or rows containing the repeating data. Right? We're flattening the table, okay? Or by repeating data along with a copy. Okay. So now let's talk about what the second normal form. So first normal form, let me go back for just a second. So unnormalized to first simply means that first is now we just have a grid where before we could have the table could have like merged cells in an Excel spreadsheet or repeating groups of data or cells with multiple values. Those are not allowed anymore. It's just a big grid, every cell is filled. Okay. All right. So now what is the second normal form? Right, so it's based on the concept of full functional dependency. What that means is, if you remember what full functional dependency meant, it meant that every column in our database table is fully functionally dependent on the key. Now, remember, if a column is dependent on part of the key but not all of it, then it's not fully functionally dependent on that key. So what that means is that if we find that there is a column that is dependent upon one or more columns that's a subset, not the whole primary key, then we're going to take that and we're going to make it its own table. Okay. So we identify the primary key for the first normal form. I identify the functional dependencies. If a partial dependency exists on the primary key, if something is dependent on, if you remember, okay, if we have something like this, okay, but we also know this, what that means is we have a partial dependency. A determines C, A, B determines C. What we can do is we can take this and make it its own table. We can make it its own relation. And we can remove that column from this table because now it exists here. Okay? And we make it its own table where we put a copy of A into our new table. Okay? All right. So finally, the third normal form is we're trying to get rid of transitive dependencies. Now remember I said that if if we have this transitive dependency, A determines B, B determines C, that's okay if B and C are in a separate table. It doesn't really affect us, but if they're in the same table, that encourages redundancy and can cause us some update anomaly problems, right? So what we're going to do is, if we find that there's a transitive dependency that exists, we are going to take that and make it into its own table. So we're going to identify the primary keys of the second normal form. We're going to identify any functional dependencies that exist there. And if we find a transitive dependency, so if we have A determines B and C, but we also have B determines C. Now notice this is not a partial dependency. A partial dependency was where a column was dependent on a part of the primary key but not the whole. This is a transitive dependency. This is where a column is dependent on another column also in the table. Okay? What we do is we'll take this, make it its own table, and remove the column from here. Okay? All right. So some general definitions before I end this video and we look at our example. The second normal form is a relation that's in the first normal form. Remember, first normal form is just every cell has a single value. Okay, no repeating groups. Second normal form is a relation that is in first normal form, and a non-primary key is fully functionally dependent on any candidate key. And the third normal form is anything that is in both first and therefore second and therefore first normal form, and in which no non-primary key is transitively dependent on any candidate key. Okay? All right. So I know that all this is maybe a little bit confusing. So what we're going to do is now we are going to look at an example in our next video, and hopefully it'll be a little bit more clear about what all this stuff means and how you can use it to create your group project. All right. I look forward to seeing you guys there.